Oh, yeah. Can you get that for? All right, homework. Let's do today. Come around, pick it up. The homework that's due today. Thank you, thank you, thank you.
We love homework.
I think I gave it out Friday of last week. Yeah, that one. Okay, that's fine. I'll still take it most of the time if you need to, because you forgot that there was supposed to be an assignment. All right, so let's see. Oh, dang it, I started my thing already. All right, so let's go. So class. All right, that's not bad, not bad, not bad. Remember, okay, you're faking like you want to be here, and then at some point you forget that you're faking.
All right.
Yes, please. Just right there. All right. So, representing motion. So a lot of the stuff that we're doing today is actually the formulas and how you read the formulas, because it is written in different ways. Kinematics is a way of describing the motion of objects without describing the causes. You can describe an object's motion in words, mathematically, or graphical representation. So we're going to do all of them. Okay, no matter how we describe the motion, there are key variables that we use. So T, another way that we could actually see that one is delta T, which is going to be my change in time or the amount of time that we have. So you could see that either way. So you could see this as a delta T. Next one, so time is going to be represented in seconds. Acceleration is meters per second per second. So now you also could see this as acceleration sub x. You can see acceleration sub x, so that would mean that my acceleration for x. So we could have acceleration in different directions. We could have an acceleration for y. We could have acceleration for x, depending on, like, we could have different rates. It could be going in different directions. So we're talking about two different lines. So acceleration or x, or it could be acceleration of y. Let's see. So x or y displacement is in meters. So for those people that keep forgetting what my units are, it's right here. V sub 0 or V sub naught, that is my initial velocity. So I also have written it as V I. Final velocity V or VF is going to be meters per second, just like initial velocity. G or A sub G, acceleration due to gravity. That again is in meters per second per second. Now, anyone tell me what gravity is? What do we use for gravity? What's the numerical value? No one? No one? It is something I have discussed before, but so you know, my gravity (9.8 meters per second squared). All right, there are three major kinematic equations that can be used to describe the motion in detail. All are used when acceleration is constant. What does that mean? What does constant mean? Zero? It could be zero. No change. Acceleration has no change. So if acceleration has no change, that means my velocity could change. So if my acceleration is positive, that means that I am increasing, my velocity is increasing over time. So it is increasing. Now, if my acceleration is negative, that means it's going to be my velocity going down, depends on what it is, right? So it is going to change my velocity, or acceleration, a constant, 0 is still a constant. So that would mean that my velocity could be the same. So if acceleration is 0, my velocity is not changing. All right, now all these right here are do the next one. So the first one here, we're going to do a little bit of algebra to go along with this, so we can show what this actually is. So this here is my formula for acceleration, which is the change in velocity over change in time. Right here, here is that, my change in velocity over time. And it comes out to here. Now, from this right here, algebraically, I could make it into that using just algebra. What would I do to my v sub naught to actually get it away from the left side of my equation? How do I undo this minus v sub naught? Algebra here. Huh? I almost heard something.
Add it.
Add it, thank you. That's what I need. I need someone. So plus to both sides of the equation. Like I said, this is algebra. All the algebra rules apply. So add it to both sides. And so once I remove it from the left side, I now have this equation, which is v is equal to v sub naught plus acceleration times time, which is happening over here. We added it to both sides. And that's how we got this equation. Now we're going to actually change it up a little bit. Now I'm going to change it up. So these right here mean the same thing, but this would say this is the velocity of x is equal to the initial velocity of x plus acceleration of x times time. The one below it is the velocity of y is equal to the initial velocity of y plus acceleration of y times time. That's how we read through those. So I'm going to use this one here, and we're gonna change it up a little bit. So that was my v equal now in this case here, I actually have 4 different variables. And I'm going to use algebra right now to give you the different formulas to solve for each one of those. We started over here. This acceleration is equal to this here. We multiplied both sides by time and got the AT here is equal to this. So I'm going to start by subtracting v sub naught to both sides. And I'm going to try and get the t by itself. If I divide both sides by time, I will have my acceleration formula, which we had on the previous page. But I don't want to do that. I want to get time by itself. So to get time by itself, what would I do to both sides? Divide by a, my acceleration, which is same as saying so you could actually see it like this as you're plugging in these items, or we could actually say, or even just be given my change in velocity. So you could be using any one of these here to solve for time. These are important because if you have all of them, all the algebra is done for you. All you have to do is plug in the numbers to the right formula. Still writing? Okay. All right. Now, I'm going to give you guys 1 minute. I want you to read through this, and I want you to find out and label with the variable, because that's what we're doing, with what it is and what does that represent. So all the information, read through it, and tell me. You're going to list 3 things that we have. There's actually more than 3, but I'll be happy to read. And go. Alrighty. Let's see. So starting off, someone throw out something what we know. Anyone? Initial velocity. So my initial velocity is going to be 1.5 meters per second. All right, what else do we know? What is it? Acceleration. Acceleration is it 2.4? Yeah. Someone different. What else we have? Go ahead, Anthony. Which is? Yeah, very good. So we have time, which is 5 seconds. There we go, right? Roberto, what do I want to know? Okay, so that means I'm looking for the what? Speed, but what is speed? It's your velocity, but which velocity? Say it one more time. Very good, because we already have initial, right? So I'm going to have velocity final is what I'm looking for. So writing things down and actually listing all the things that you have is going to be key for what formula you're going to use and what you could solve to get there. All right, so I'm going to write this out. Hold on. I'm going to make some more room here. All right, so my formula here. So I'm going to write out the formula. My formula was, I have velocity is equal to my initial velocity plus acceleration times time. Or velocity final, same thing, right? So that's what we're looking for. So initial velocity. So we have V equals initial velocity, 1.5, plus acceleration, which is 2.4 times 5 seconds. We're just throwing it out there, just a little bit. It's all right, as long as you come back. All right, so please, someone, I need you to math this, especially if you don't know how to use these calculators very well. Practice using these calculators. Just at least, practice putting it in, practice hitting enter. You're going to find out that your calculator might be in the wrong mode and you need to know how to fix it. Someone actually had that problem earlier. What answer we get? 37.5. Okay. What are my units? Meters per second. Just like in that second slide, it tells you what your units should be. That's key. All right, can I move on? Yes. Same problem. I want you to list again what you know. But now we know some more stuff. There's one more thing you have to get out of the reading. All right, so going through, this is the same problem. I have the same starting information. My initial velocity, 1.5. I had my acceleration, 2.4. I had my time, which is 5 seconds. My previous answer my previous answer was the velocity final. There we go. Now, if I'm looking at my formula beforehand, what is that? What does x sub naught mean? The what? That's just my delta x. That's delta x. X sub naught. What did I call it if it is my sub-zero thing? It's on the first page, but I did sub-zero for velocity. Huh? What does that little sub-zero mean? Initial. Thank you. That's what I needed. There it is. So right here, initial. That little zero at the beginning means it's initial. So since it is the x sub-zero, that should be my initial position, right? My starting position. So since I'm looking at my formula, these are all the things I need to know. So what was my starting position? Read through that. What is my starting position? This is something you have to get from the reading, like understanding what you're reading. I have a few people looking at the reading, understanding what the reading is saying. What is my initial position? Yes, it is. It is zero. Especially in these readings and these problems and stuff like that. Reading through it and understanding we're starting from somewhere. We're in a car, in a boat, in a plane. We start somewhere. So my initial position, if it doesn't say anything else, it's normally going to be my initial position is zero. Now, what do I want to find? What do I want to find? Read through it. What is it I'm looking for? The distance, which is going to be my final position. Very good. What's another word? What's the variables I'm using for that? Displacement. Very good. My displacement, my final position, where I'm ending up. Now, what am I going to write up here, though? What symbols? What symbols I use for displacement? Huh? Except I can. Or delta x. My displacement, my change in position. So that's what we're looking for. We're looking for that x value. So I got the formula right here. There's my formula. And I just need to start plugging in. So once I have all the variables that I'm looking for, I could use the formula and I could solve for other things that I don't know yet. Sometimes you might actually need a secondary step after this. We have formulas that go directly to what we're looking for, but sometimes we need this value to get to the next value. So we have x equals 0 plus 1.5 times 5 plus 1/2, 2.4 times 5 squared. So if you could, go ahead, throw it in your handy dandy calculator. Do we have an answer? A little bit louder. Okay, what are my units? It's just x, right? Just x, so that's just m by itself. All right, that being said, let's go. All right, so now what this is from my formula, we have the triangle. Because we learned this on Wednesday, we did areas under the graph, right? Areas under the graph. This one here starts at 1.5 though. Starts at 1.5, so I get a total distance for this one right here because this area, I have a rectangle, very skinny rectangle here. Plus, I'm starting at 1.5, so my triangle is shifted up to that point right there. So therefore, the area of this triangle, 1/2 base times height. So we end up getting 30 for this. And then when I add them all together, finding graphically, by finding the area under the curve, I get 37.5. Isn't that what I just had a little bit ago? Yeah. So this line right here represents my constant acceleration. And here's where it is derived from. So we have our triangle. If you notice, we have the triangle and we have the rectangle. So the rectangle part is just right here. We have the rectangle, which is going to be this, which is height times base, my velocity, my initial velocity, time of x times time, which is going to be here. Then I have over here the area of a triangle, 1/2 acceleration times time squared, which is actually breaks down into acceleration over time. So it's actually the change in velocity. So it's the slope times time. The slope times time. So it actually works out to be exactly the same as area of a triangle. So as we add those together, we also had a starting amount. We started not from 0, but we started from 1.5 off the graph. So most of the time, x of naught equals 0, but if it's not, don't forget to add into the initial position of the object. That being said, questions, concerns, complaints, conspiracy theories? Any conspiracy theories? No? All right, I'm gonna pick up on this one on Monday. If you did not finish your AP classroom, that is due yesterday. If you did not finish your homework, that is due today. And all the videos in the AP classroom, if you haven't done those yet, those are due today. Make sure everyone likes, share, and subscribe. I'm gonna let you guys use the rest of this class time to try to work on either homework, not to just sit there and play on your phone. Anthony.